Welcome back, everybody. I hope everybody is fine. This is a second lecture on solving trigonometric equations, and this time I want to discuss quadratic trigonometric equations. So we have a trigonometric equation which is given in factored form, and the product is equal to 0, and we want to solve this for x such that x is between 0 and 2 pi. That's the given interval. Now, because this is already factored for us, so all we need to do is to set each factor equal to 0 according to the zero product property in mathematics. We know that if the product of 2 or 3 expressions or binomials is equal to 0, then either the first or the second must be 0. So we're going to set each factor equal to 0. So we're going to say either the first expression is 0 or the second one is equal to 0. And this way, we end up with two simple trigonometric equations that we have discussed in the past. If you solve for x, you get root 2 over 2. And here you get cos x equals negative root 3 over 2. These are two simple trigonometric equations that we have discussed in the past. Now, how do you find it? We can cheat from the formulas discussed. X sub 1 would be inverse cosine of root 2 over 2. But we know the cosine of a 45-degree angle as a special angle is root 2 over 2. So we don't even need to use a calculator to tell you the truth. And the answer would be pi over 4 radian. Okay. The second solution is always for cosine, it's 2 pi minus inverse cosine of k. So it will be 2 pi minus pi over 4. So 2 pi minus pi over 4 would be 7 pi over 4. If I convert these into degrees, 45 degrees, and this other one will be 315 degrees. But we don't convert because they give us the domain in radian, so we're going to just write the answers in radian. If somebody says to you bonjour in French, you don't respond in English saying hello, obviously. Okay, so these are the two solutions, pi over 4 and 7 pi over 4. Maybe I can somehow put them in boxes. These are the final answers. For this other part, x sub 3, I should say now, because I used x sub 1 and 2, would be inverse cosine of negative root 3 over 2, which if you use a calculator, it's going to give you 150 degrees, which is 5 pi over 6. And even if you don't use calculators, by drawing a diagram of an angle in standard position, you will figure out that cosine of 5 pi over 6 in the second quadrant is negative root 3 over 2, because root 3 over 2 is one of those trig ratios of special angles. And x sub 4, again, it is going to be 2 pi minus 5 pi over 6, which is going to be 7 pi over 6. Okay, so if somebody says what is the solution set, so solution set for this trigonometric equation, we're going to say pi over 4, 7 pi over 4, 5 pi over 6, and the fourth one is 7 pi over 6. So this is going to be the solution set for that trigonometric equation. All of these solutions, as you know, they are within the given domain. We don't need to find the coterminal angles by adding or subtracting 2 pi, and that is the final answer. Next exercise is a quadratic trigonometric equation, clearly, because we have an exponent of 2 for sine x. In these exercises I did, the exponent of cos x was 1. But here the exponent of sine x is 2. That makes it quadratic. So just for simplicity purposes, I let sine x equal to some variable z, and I end up with 3z squared minus z minus 2 equals 0, which is clearly a quadratic equation at grade 10 level. Now we can solve this quadratic equation by using quadratic formula or sometimes by factoring if it is possible. So let's see if it is possible to factor this. So 3z and z, the product would be 3z squared. So perhaps 3z plus 2, z minus 1, if you do it by trial and error method, or you can use traditional methods such as decomposition method and factor it. End of the day, you end up with this product z minus 1 times 3z plus 2 equals 0. Now, again, using zero product property, we're going to say either the first or the second binomial must be 0, which means that z is 1 or z is negative 2/3, basically. Let us not forget what z was. We just changed the variable from sin x to z for simplicity purposes, but we have to remember that z was nothing but sine of x. So here, basically, we're saying sine of x equals 1, and here we're saying sine of x is negative 2/3. And these are nothing but simple trigonometric equations. So sine of x is 1, then what is that angle whose sine is equal to 1? Everybody knows it's 90 degrees, or you may say it is pi over 2 radian. Either with the calculator or without the calculator, you may be able to find the answer. For this case, x sub 2, we have to take inverse sine of negative 2/3. It's right there. I have not erased the board yet. And the answer is 3.8713 radian if your calculator is in the radian mode. And the third solution, cheating from there, is going to be pi minus this number. Pi minus this number. So 3.8713. Let's check this with the calculator to make sure it is correct. So I'm finding inverse sine. Turn on the calculator. Inverse sine of negative 2/3. That is negative 0.729 actually. So see, it was not matching. So what I get here, to be exact, is negative 0.7297. This is what the calculator gives me. And this is a negative angle, which is not in the given, it's not within the given domain. So I have to make this, to be within that given domain. And the only way is by adding 2 pi, finding the first positive coterminal angle. So if we add this with 2 times pi, okay, then you get 5.5. So this is x2, which is inadmissible, but then x3, let's find x3 here. It would be 2 pi plus this negative answer in radian, which would give you 5.553, let's say 4. The next digit is 5, so I can round it to 3.5, let's say. Okay, depending on how many digits after the decimal point you want to consider for your accuracy. So this answer is admissible. The other one is not admissible because 2 pi is 6.28 radian, but this one is 5.5 radian, so it's less than 2 pi. Therefore, it is admissible. So that's that. Now, x sub 4, before we forget, it is pi minus the angle we had before on the screen. So pi minus 0.7, it's going to be pi plus actually. So I go pi minus and then negative 0.7297, and that would be 3.87, which is what I had before, I believe, 3.87. So 3.8713 radian, and this is also admissible. So making a long story short, solution set for this quadratic trigonometric equation is going to be pi over 2, and then it's going to be 5.55 radian, and it's going to be 3.87 radian. So these are the three solutions within the domain of 0 to 2 pi for this particular trigonometric equation, of course. Finally, another example. Again, this is a quadratic trigonometric equation, and you see the exponent of 2 for cos x this time. But the thing is that if I want to use the trick I used earlier here, I let sin x equal to z, and I came up with this quadratic equation quickly. I can't do that because if I let sin x equal to z, so I end up with 3z, of course, but here this is not sine squared of x, it's cos squared of x, so can't do anything. And that's why we have to, again, use trig identities here. So I'm going to go 10 times 1 minus sine squared of x. Instead of cos squared of x, I use Pythagorean identity, and I substitute 1 minus sine squared of x instead of cos squared of x. And this way, I will be able to express the whole equation in terms of sine x. That's the trick here, using the trig identity. And I move all the terms to one side of the equation. So now I simplify negative 10 sine squared of x plus 3 sine x. And this is 10 minus 9 is just 1. And if you multiply both sides by negative 1, so this becomes positive, this becomes negative, and this becomes negative. So we end up with another, actually, quadratic trigonometric equation. But this one is just like before, is like easy, because you can again let sine x equal to z or some variable. I pick t here for a change, okay? And then you plug in and you get 10t squared minus 3t minus 1 equals 0, which is a grade 10 quadratic equation, to solve or to deal with. And it's not that difficult. We can do this by factoring, or if it is not factorable, don't worry about it. You can always use quadratic formula. So 2t minus 1, 5t plus 1 would be the result of factoring this quadratic trinomial. So again, zero power property, either 2t minus 1 is 0, or 5t plus 1 is 0. T would be 1/2, or T would be negative 1/5. Now let's not forget what T was. T was sine of x. So now we have to do a back substitution at this step. So we go sine of x equals 1/2. Sine of x equals negative 1/5. So if sine x is 1/2, obviously the answer would be 30 degrees or pi over 6 radian. So x sub 1 would be pi over 6. And the other solution would be pi minus pi over 6, which is pi minus pi over 6, which is 5 pi over 6. So one solution, and this is the second solution for the first trig equation, simple trig equation. So we had a quadratic trigonometric equation which was converted eventually into two simple trigonometric equations, and now we are solving the simple trigonometric equations like before. So this one, this is x sub 3. It will be inverse sine of negative 1/5. Again, we have to use the calculator. So let me see what is inverse sine of negative 1/5 equal to. So it's negative 0.2013. Okay, this is all radian. I'm going to add 2 pi. So I'm adding 2 pi, and I end up with 6.0818. So 6.0818. This is x sub 4. The answer is in radian. It is less than 2 pi, therefore it's admissible. But x sub 3 was not admissible because it was negative. Not that because it was wrong or your calculator was wrong. No, it's because it was not within the given domain. Where is the domain? Right here. It's between 0 and 2 pi. Now, what about the second solution before we forget? So x sub 5, it says, this is sine, right? Pi minus. So pi minus negative 0.2013. So we have the final answer, 3.343. So 3.343 radian. Okay, so now the solution set for that. For this trigonometric equation, I'll write it at the bottom. It would be pi over 6 We had it before. 5 pi over 6. It's all in radians. 6.08 and 3.3 both are in radian, of course. We don't write radian, but if it's degrees, you put the little circle at the top right corner. But it's not customary to write the radian. When you say pi over 6, automatically it's understood that it's in radian. So 1, 2, 3, 4 solutions. All 4 of them are within the given domain. And this was the quadratic trigonometric equation, which we used the trig identity at the beginning, and then we converted that into a quadratic equation and solved it. We ended up with 2 simple trigonometric equations, and using the techniques and methods we have learned in the past, we found all 4 solutions for that trigonometric quadratic trigonometric equation. So I hope these 3 examples I gave you. So one was here, okay, and one was here. Yeah, I hope these 3 examples you found helpful. And of course, it's never enough, and you have to keep practicing. And I suggest you do many questions. You solve many tricky questions so that you become very fluent in it. Thank you for your attention.